Welcome, everyone. Thank you for joining us today for the webinar. My name is Odette Hines, and I'll be your moderator for the webinar entitled Programming with Arduino IDE. Your presenters today will be Armagan Ibrahimi, who is a partner solutions engineer at Sony. She works at different divisions at Sony to bring in innovations to developers and businesses to build scalable solutions. She has over 20 years of experience in the high-tech industry with a mixed background in hardware and software engineering. She has worked on chip-level verification on ASIC and FPGA, all the way to video player on Android and iOS devices. She supports Sony Spresense in North America. Our next presenter is Kamil Tamisuski, who is a developer program engineer at Sony. He's one of the major contributors to the Spresense technical support. He has ported CircuitPython on Spresense. He also supports Spresense documentations by building demos and tutorials, as well as interacting with customers and developers who have had technical questions on the forum or even at events. Before we start today, I want to provide you with a few housekeeping rules. All participants are in listen-only mode. If you have questions during the webinar, please type them in the questions section in your GoToWebinar control panel, and I'll ensure that they're answered at the end of the webinar. If we do not get to your questions today, we'll send the answers to you via email a few days later. The on-demand version of the webinar will be available within the next few days, and I'll ensure that it is sent to you as well. If you require a conversation or a demo, please ensure that you put that request in the question section of your GoToWebinar control panel, and I'll ensure that they're directed to the presenters at the end of the webinar. After the webinar, all attendees will be entered into a draw to win a Spresense kit, which includes the extension board, the camera board, and the main board. The winner will be announced on June 30th at 11 a.m. Eastern Time. Now, without further ado, I'll pass this over to Armagan. Armagan?
Hello, everyone, and welcome to today's webinar. Thank you, Odette, for introduction. My name is Armagan Ibrahimi, and today I will be covering Sony Spresense programming with Arduino IDE. I'm glad everybody's here. I hope you are staying safe and healthy during this pandemic. So let's start with this webinar and see what we are covering throughout this today's talk. But I'm covering first what are the key takeaways from the webinar number one. This is our second webinar, so I thought it's better to touch on those key takeaways that we had for the first webinar. And then also I will cover some brief introduction to Spresense to just give those audience that they didn't get a chance to look at the first webinar some idea, and then they can keep up with us during this webinar. And finally, the most important thing for this webinar is we learn how to program Spresense using Arduino IDE. You need to set up your environment. And then there are three main features on Spresense that I would like to touch and talk about: camera, audio, and GNSS. So by the end of this webinar, you learn how to program those. And at the end, we have the introduction and introducing our partner Necto. Necto is a software company and basically is connecting Spresense to the cloud. And there are so many features that I would like to share with you about Necto. Let me go to the next slide. This one, I put it here, then you know what has been covered in the first webinar. Of course, we covered everything for Spresense as far as hardware, software, and in depth. And there are so many applications that you can build with Spresense. Some of those that I have mentioned in the previous webinar was Industry 4.0, precision agriculture, infrastructure, and medical. And it's very important for us to explain why Spresense is very powerful, at the same time is low power. For that, we went in at the silicon level to explain the secret of low power. And finally, there is a very cool feature about the Spresense to do multi-core programming. And for that, you can do this multi-core programming using Arduino IDE. These are the stuff that we cover. If you haven't listened to the first webinar, or if you need to go back to that, please use this link over here. And you can just access it, listen to it, and get the information. First, let's give you again, because if you haven't been in the first webinar, let's give you a brief introduction of Spresense. What is Spresense? Spresense is a development kit and is targeting IoT application. We think what is important for IT application is low power. Spresense is a very good choice if you're building something with requires low power. And also Spresense is very powerful. It has 6 ARM cores. It has 156 megahertz of clock. And if you see, as you see in this in this slide, on the right hand side, these are the main features that we would like you to pay more attention to. What is it? Is low power, it has 6 ARM core, and we are saving a lot of power while we are accessing the memory. We are using ASMP framework, and it has the high resolution audio. We are proud of it. We are Sony, so this is another feature. And then we have the position featuring. We are covering the globe. So we have GPS in the US, GLONASS, QZSS in Japan, and so on. If you want to get more information, let's look at on the left-hand side. So as I mentioned, 6 ARM cores and 156 megahertz of clock. And then this is the memory that you have access to. We have digital input, analog input, and for audio, we have 8-channel digital mic, 4-channel analog mic, and so on. GNSS is covering GPS GLONASS, as I mentioned, and then other features is like camera interface, so to make it easy, so to build your application. Let me show you the hardware part also. Then what you see in this slide, you see the main board right in the middle. This is the main board that we are supporting with camera board and extension board. When you build your application, this is what you are going to work on. We give you extension board if you need to access to, for example, a SD card, or if you need to have a headphone, if you will need to get the audio out, it's very easy to have a headphone jack here. And also you can put Arduino shells on top of this. The camera is a very simple camera that you can connect through this interface that you have on the main board. So after we say this, so now you have the big picture of the spec. What is a Spresense, high resolution audio, IoT, low power, and all of those. Now, when you want to build anything, you need to know what are the pinouts for your board. And this is very simple. This is going to be your reference when you build your applications. I included here, and I would like to talk about some pins that they are exclusive. Some of them are shared. When you look at this pinouts, you have the main board on the left-hand side, and you have the extension board on the right-hand side. Main board is both boards are supporting GPIO, UART, and so on. These are just universal. In any other boards, you see this. But when you look at UART, for example, when you look at UART, we have serial and we have serial 2. What does it mean? Serial is available on main board, but serial 2, you can have it on. You have access to it on both main board and extension board. But if you're using it on main board, you cannot use it on extension board. So when I say exclusive, this is what you need to keep in mind. If I'm using this on main board, then I cannot access it on extension board. Just keep that in mind. And the rest, like for I2C, we are sharing pin 14 and 15. And also I have put the associated voltage for each of these pins here. Like for example, for GPIO on the main board, we have 1.8 volt, and then for extension board, we have 3.3 and 5.5 volt. So now I hope I covered enough for us to start, and I may come back to this page again when we start building our projects. And so now let's start with the fun part. Now we want to do what? We want to do Spresense programming with Arduino IDE. For any development, first we need to do what? We need to prepare our environment. We need to do the setup, do all of the installation, and next step is going to be the building and development and programming side of it. So first thing that I'm going to cover is preparation for development. Preparation for development is covering Arduino. So this is Arduino IDE. So I need to install that. I'm sure all of you have done that so many times for other boards. So you need to have your software in, and then we need to install the driver. The driver here is for your connection. So you have a cable that is coming from a Spresense board to your computer. So this is the driver for that. And then we need to bring the Spresense Arduino library, of course. And then at the end, we need to burn the bootloader and put everything on a Spresense. What I show in this section is going to be step by step. I wish we had a live workshop, we could work together, but this is going to be still very helpful and very easy to follow. So Spresense is not very complicated. Even you take it out of the box, you can just connect it and start using it. So it's not very complicated, and I hope you find this just a reference and install the Arduino and set up for your environment. So install the Arduino. This is where you can get the Arduino. There are different versions. This is the latest, I believe, that I have included here. After you install, this is your software. After you install this, you need the driver. As I said, this is how you connect your board, a Spresense board to your computer. So you need to install this driver. Of course, it depends on your platform. For Linux, you don't need to install anything, it's already included. I would like to mention that. And then let's look at the step-by-step. Again, this is very simple. Just I put it here, then you have a reference and you know how, when you start with Spresense, how to do it. So here on the top, you will see this, on the top, you see this Spresense Arduino library getting started guide. You will find a lot of good information if you go to this link, but it's too much detail I'm not gonna cover. For here, what we need to know how I can get the Arduino library, Spresense Arduino library. You need to go to additional board management, and then you need to add this link that I provided here in the bottom to your to the URL as you see here. So you can add it there, and then the next step is you have to go to board management and then select the board management, and then when you go to the last step, which is the Spresense Arduino library, you will see the Spresense there, and click on it. Can I advance this? I'm sorry, I think I am. Okay. So then you see these are the steps that you do for the Spresense Arduino library. And do you see my next page or no? I think I am just going, okay. A little bit of confusion. Can someone tell me this is okay? So you have the Spresense reference board, and then the next step is to burn the bootloader. To burn the bootloader, you will follow these three steps. So you need to have the Spresense firmware updated, and then you need to do the burn bootloader. And the last step, when you do all of these things on the black part of the Arduino IDE, you will see all of this compilation, and then it tells you reboot. Means everything is done, and you have downloaded everything, and then you have the libraries on the Spresense board. And for that, after you do all of these things, you need to make sure everything went through. So when you look at your board, you will see this blue light already on, means your board is on. And then the connection for the PC and your Sony board is already in place. And also here, just pay attention to this. We have a reset button, and this reset button is starting you, and you can, when you write your program, this is the button that you can use, which is very helpful. So up to here, you have all of the software, all of the hardware working. And now let's write our first program, right? So to write our first program, this is very simple. Spresense has 4 LED already on the board, is integrated there. And then you can add those LEDs, you can turn them on and off, and you can use this feature for testing, debugging, and so many other things. And make sure your board is all connected. So this program is very simple. Is accessing for 0 to 3 LED. So if you can see LED 0, LED 1, LED 2, LED 3, and then after you program this thing, you turn all of them high, or you can say high, low, or you can add a you can make a loop, and then you can make this thing blinking, make the LEDs blinking. And so this is your program, just few lines, is what, like 13 lines. And by the way, for the Arduino language, let me just go back. So for Arduino language reference, please use these links here. And it's very simple, it's very similar to C. And for when you want to run your sketch, is very easy again. So you need to select your port, And this port is where your hardware is connected to computer again. And then you need to click on update, and when you do click, and then it start compiling and running your program. And then again, you see the reboot, and what you see next is here. So you see this LED, you see this green lights on. This means your program is successful. I turn all of them on, and you see this here. Very simple and easy. Most of the time I keep this program handy, because when you add all of your sensors and you are building something, you may need to double check to see, is everything okay, if I'm connected, or to check and debug. And this is a good program. This is the first step. Now everything is set up. You have the hardware, you have the software. So let us go to the next step, which is the building with Spresense using Arduino IDE. So let's see what we can do here. First thing that I would like to cover here is camera. I told you, camera, audio, and GPS is going to be covered in this. These are just a basic concept and building block for you to start with Spresense. Camera is camera in this part of my talk. I will connect the LCD to Spresense to display, and also I have two sketch. I will cover two programs here. One is the preview on LCD, and the other one is take a still picture with the camera. I think with these two, you will learn the basics of accessing the camera and use this feature. There are so many IoT applications like surveillance cameras, AI cameras, like targeting some application that you need to do some, like watch your machinery at the factories to make sure it's up and running, and do maintenance and predictive maintenance and so on. So this is just a building block, and to learn how to access the classes and libraries and everything that we provide with camera. I told you display. The display that we are using here is ILI 9341, is a 2.4 inch TFT LCD, and this has all of the pins that you see on the right hand side from this LCD should get connected to Spresense. Okay, remember, I told you about the map at the beginning. This is where you use it. So you know all of those pinouts, and you know you need to connect, for example, to ground. This is how you connect to ground. Or if you have a chip select, you need to connect your chip select. Very simple. And one more thing that you need to remember is you need to set the I/O voltage. So here we are setting this up to 3.3, and if you look at this little box here, it shows you how. These are very simple. So you just connect everything, and then you have your display connected. Okay. After doing this, we have our display, but our display without the library doesn't mean anything. I have to add the libraries to Spresense to recognize this LCD, right? For that, we have two zip files that we provide with our with a folder that I will include all of the programs for you. This two zip file, it will add Arduino, Adafruit libraries to access the LCD. And then you need to add this to your libraries on Arduino IDE. It's very simple again. So you go, if you look at this little box, step 2, it tells you exactly how to add those libraries. And to check to see if the library is there, or maybe you put the wrong library, you need to remove it. Just go to Arduino folder on your computer, and just go to libraries. Then you can remove or add, and then you can check if the library is already there or not. So this is, so you have learned, you know, that LCD, how you connect it, you have added your libraries, and then this is what's gonna happen. This is what you see. What you see, this is your LCD, and then did I mention about the buttons? Probably I know. So here I add a button to, just to make it more fun. So we have a button that you can click, which I'm gonna use in the other camera example. But so here, you have the LCD, and then then you have the camera. I told you on the main board, we have an interface for the camera. You just slide it in. but be very careful with the flexible side of the cable. We have documentation to cover this, but just keep this in mind. Look at this blue side. This has to show when you connect your camera, and then this is the right way to connect the camera. Okay, now let's look at the sketch and see what do we have for the camera. For previewing the camera, what you see in this page, this is all you need for connecting your display to a Spresense. Very short, right? So for you, of course, this is camera. You need to add the camera.h. This is your library to access the classes and camera features, and these are just a bunch of defines to connect the select and reset and others to your screen. This is TFT. When I say TFT is display, then you initialize your TFT to say which pins are connected, and you see this big red box. Let me get back to this. This is just the callback function, but callback function is when you want first you need to get the picture from the camera, show that, and then eventually show that on the TFT, right? So let's go to this part, that is the setup. For this one, we need to start the TFT because that's our display, and then we need to select the rotation to say if it's vertical or horizontal. These are just very basic steps that you do for any display, and then you need to call the camera class, and then start camera. So when you say begin, you're starting the camera. And then at this point, we are doing what? We are doing streaming. Streaming that it goes to our display. For that, we are using the camera that starts streaming. And you pass two parameters here. We have true and we have a callback, as I mentioned in this red box. So you have a callback that you register here. So you basically, whatever you're streaming, you show on your display. Keep in mind that until you have this parameter, the true, you are streaming. And if you want to stop streaming, you change this to false. Let's go back again to this function, this callback function, and see what is happening. So this is nothing but changing the image to the format that you need on your display. So for example, here for the camera, we have a different format, and when we get to the display, then we need to change the format, and then this is how you can display it. So you have that. So now we have the TFT. We are done with our first program. Let's do this. Let's go to the next one, which is now taking still pictures. So it's taking a still picture. For that, I am just adding this part to the previous program. So if you see some TFT, it means this program has both TFT and also taking a picture. So to take the picture, we added, remember I told you about that button. So we added a button, means when you click, you take first click is going to take the picture, and then when you click also you turn one of the LEDs on. So what you see in this program, you have and then we need to save that picture somewhere. We have the micro SD card on the board, on the extension board, so we save it there. The whole process is gonna be this. So you have the camera, you point to the target that you want to take the picture, and you click on the button, means you are taking the picture, the LED goes on, and then the picture gets saved on the micro SD card. So and here you see like this class, for example, SD class. This is for your micro SD card. This is how you. So this is how you initialize your SD card to be able to write to put the picture over there. And then we have we need to take care of the button to turn button to take picture. And so for the LED, you see the code here, and you need to start the SD card. And let me go to loop. So everything is happening here, and then it gets first you need to turn the first. By the way, when you do all of these things, you have your serial monitor always open, and you see this action. So when you click on the button, you see this button press. So it means that you have pressed the button, and then you took the picture, and LED goes high, so I know that I took the picture, and then camera start working and taking the picture, and then whatever picture that you take, we need to write it on the SD card, and this is the process for that. And then at the end, you just turn the LED off. So I think I covered these two programs. By now, you understand the basic concept for camera, how to access it, and two main functions that you can do: display and you can do taking picture, right? I include this here. Now this is for you to try this. These two programs, that preview and take picture, is available to you. And also to support that, you can refer to Spresense Arduino camera library, and you can find all the other functions. So we will provide all of these programs and stuff to you. But for now, this is what you have, and you can start. And by the way, let me tell you this: for Arduino examples, we have, if you download our SDK, we have an example folder that it has all of the building blocks for Spresense. This is a specific. Here I added some camera or other some buttons or different logic. But if you want to find the basic one to access the camera, we have a folder with camera, so you can do take picture, or for others also, for audio and GNSS. So everything is available that you can start with. Just in case you don't get this file, don't panic. You can access it. You can access a different one there, but those are helpful, and you can start your development with them. Next thing that we are covering is audio. Audio is exciting. We have high resolution audio. You can target so many applications with this. We have built so many demos to, for example, listen to a piece of listen to a machinery at the factory to see if it's working properly, and if it's not, then we can detect that noise and take action, like this machine is not working. So audio is powerful. For audio, we are providing audio play, and also we can do recording as like microphone, use a microphone to do recording. First part of this section is going to be audio player, and the next one I'm going to cover the recording. What you need in this section is we are using, I told you, we have the Spresense extension board. You have a headphone jack, you can have the audio out from there. So it's very simple to just get the audio out. You use the extension board, main board, and you need a SD card because your music sits there, but I will cover that. So for in this section, you have the you have to install the decoder, because you have audio player, or if you do any recording, you need to do DSP codec should be available on the board, and that is a step that we take. So for any audio, I think you are familiar with that. And then we are supporting MP3 and WAV for format audio format. For our audio, and I think, yes, so the main feature, as I said, is sound recording and also audio player. And I have a very cool thing at the end. I tell you how you can connect Spresense, the small Spresense, to a speaker out, which is amazing to have a small board being able to have a that output to a speaker. Okay. Again, so we are looking at this picture. You see the extension board, and you see the main board, adding a button again to make it more fun. And you need a SD card, and this is your little speaker, or you can use a pair of headphones. So this is just like your headphone jack anywhere, so you can connect it to Spresense. And for the steps that I told you, first we need to install the decoder. To install the decoder, we have to go through these 3 steps. So first we need to go to example. This is what I told you. So the example folder in Spresense, look at all of this. These are all the examples for Spresense. You can do audio, camera, everything. So in this section of my talk, I'm going to go to audio. So for audio, I need to do the I have 2 section, application and DSP installer. DSP installer is for encoder and decoder. I select the decoder, and then after I select the decoder, I let it run, And after it runs on the serial monitor, you have two options. Either you can go with SD card, or you can do SPI flash. So in this example, I'm using SD card. SD card is nothing but the SD card that I have on the extension board. So so now we have that. These are the first steps for preparing this decoder. And now let's look at the code. For audio, we need to instantiate it. At the beginning, you see we have the audio, and here is the audio class. So we instantiate it at the beginning. And for this audio, all the music that you have, it goes on a file, and you put it on your SD card. We call it sound.mp3. And then these are some functions that we need to set up. We need to have player start, player end, and the volume and all of these things to set up our player. But the fun is happening in this side when we do the when you start the audio. What you need to set up the clock. By default, clock is normal, but we have high resolution. If you want to use high resolution audio, you need to change this parameter to AS clock mode to high resolution. And also, when you want to, you have two parameters to set up the player mode. And this is an MP3. So what I'm using here is as set player to this. This is what I'm using now. And then the output is line out. But if I want to change it and have I squared S, then for that, I need to use this parameter, which is AS setup player output device underscore I squared S output. So very simple. And also, if you want to have a speaker out, I told you I'm going to talk about the speaker at the end of this section. So if you want to use a speaker out, this is where you need to change this parameter. So you have this, and now we need to set up our player. Our Spresense has two players, player 0, player 1, and you can pick any of those. And then also you can do mixed music, do dual player with player 0 and player 1. So we can choose both of them. In this example, we are using player 0. The type of the format is MP3, of course. And you see here that I have MNT, SD, and bin. This is the directory that you put your codec. Remember at the beginning we did the DSP installer and went through that process. This is where you have the decoder for MP3. Okay, and then also here we have the the sampling rate for MP3, which is auto, and then you can have it a stereo or mono. So here is the output is a stereo. Okay, and okay, so for this I have everything. I'm going to the next box. So the next box is basically telling you have all of your music in sound. All of your sound on the SD card. So basically, Spresense needs to go there and get this music and put it on a FIFO and just start reading. To make sure this sync and this is happening correctly, you need to set up this delay at the end. So be careful. If this delay is not correctly set, which it depends on your music, it depends on what your program is. If your program is longer, maybe you need more time. So if you need to feed the FIFO. So if the FIFO if this time is not enough, then FIFO is empty. Or if this time is too long, then maybe this overflow. So be careful with this. This is not very complicated. You write your code. My code is this short, and this time is enough for me. But this is something to keep in mind to make sure that your music is sync and you can play it. Okay, so we covered the audio player. Again, this is the program that you can use. This is the library that you can refer to, and this is going to be the picture for how it's going to look like. Let's go to the next one. I think this is fun. You can connect the Spresense board, and you saw it. It's just a very small board, but you can get a speaker out. How cool is that? And then for that, you need to do some modification on the main board. The original, the default is set for this little headphone jack to get the audio out, right? But if you do the modification, this is not going to be available anymore, of course, and then you will send the audio out to your speaker. So this is a speaker that I have here, and also, if you look at, I put a little picture on the right-hand side for you to refer to. For this is our main board, and they are two. You need to change the resistor, and you need to modify the resistor, and you need to modify the capacitors here. The information is written here. So I have the green blocks and I have the red blocks here. So the green is your capacitor, and the yellow one is your the resistors, and you need to change those, modify those. And if you need more information, please go to this link that I mainboard modification to connect a speaker out. So this is the modification that you do on the board. And then also, as I mentioned before, this is the parameter that you need to add when you do the set player mode to make sure that you have the speaker out directly from the Spresense. Okay, we are done with the audio player. Let's go to the next one, is the recorder, microphone. This, we have seen so many applications that they use it, as I mentioned before, in the factories to do some recording and then analyze that and then make sure the device is okay. You can put it in a car engine to see if the car is engine is working properly, and then set notification to if there is something wrong. So the applications are, I'm sure there are so many applications to use the recording, but don't forget, this is high resolution audio. It's not any type of recording. So you can get all of those little bits and pieces of your audio that you need to do the analyze on. So, okay, recorder, what we are covering in this one is, so we need to connect a microphone here, and then we need to install what? We need the encoder. This is recording, so we need the encoder. And then I will show you the sketch for the recorder. Show you now the connection, how you connect your microphone here. To connect your microphone, these are the pins. It is simple. Again, you go back to that map at the beginning of my talk, and here we have the connector to connect the microphone. And as you see on the left-hand side, you need a SD card. You need a SD card because you record, you want to listen to it, right? So you need a SD card to put it there. And also the button is just for some features, just to start a recording, stop the recording, to make it easier to control. So this is the whole picture. Now let's see how we do the installation for our encoder. Again, this is very simple. We do the same thing. We go to example folder, we go to audio, and then we start with we do the DSP installer, but this time we are doing encoding. This is microphone, of course, we need encoding. And after you compile that, again, you get two options on the serial monitor. Would you like to use the SD card, or you want to use the SPI flash? And in this example, I'm using the SD card. So I choose option 1, and I'm all set. I have the decoder. You know how to connect your microphone. Now let's look at the code and see what is happening here. For the code, what we do before, I mentioned FIFO before. So in the previous example, you get the music from your SD card and put it on the FIFO because you want to read it. In this case, you record your audio, put it in the FIFO, and you need to send it back and save it on your SD card. So this is this program. It just shows you how to do all these things. Plus, we have a button to control. So when I click means first click, I'm starting the recording. Second click means I'm stopping that. And so for recording, you need to you see in the first block, you need to end it, and then the second one, it shows you how to begin. And when you start, then you need to communicate with the SD card. So you see how we are writing it back to the SD card. And let me go to the next page. So this is the rest of the program. And in this one. So eventually when you go to do the setup, you start when you have to click the button, and then when you click the button and when you want to do the recording, and when you access the audio class, you basically read everything, and you do the recording and you write it to the file. Again, be careful with this delay, again, because you are doing some synchronization between the FIFO and your SD card. And so by the end of this program, you are able to do recording and recording your audio, and you can play it back. You take the SD card and you can play the audio that you're recording on your computer. This is the library that you will refer to for recording, and this is the code that I just mentioned. This code that I have here, this is just it is not the whole thing, so it's just like some part of the code that is available maybe, but it gives you enough information to start with the audio recording. So we have covered the camera. How am I doing with the time? Okay, we have covered the camera, we have covered the audio. The other cool thing that is available on Spresense is GNSS. GNSS is Global Navigation Satellite System. So GPS, GLONASS, QZSS, anywhere in the world you are, Spresense can help you with locating to recognize your position, and so we have a global coverage. Is very okay. GNSS is already integrated in Spresense board, and it doesn't need an antenna. So its antenna is already there. I will show you. In this part, let me see what I'm covering. So I say Spresense board because Spresense board is enough for you to build your program for GNSS. And then also I give you some information about how you can extend the antenna just in case you build something cool and you want to add but maybe you cover the antenna and you need to extend it. And also at the end, I will show you the sketch. Let's go here now. So for GNSS, Global Navigation Satellite System, you see Spresense main board on the left-hand side, and this circle that you see, this is the antenna that we have available on the board. And it depends, so this is just to give you some references about what you are using, if you're using GPS, if you're in US or North America, or if you're using QZSS in Japan. So this is the condition or effective place under the open sky, and what is the accuracy for this place. I have tried the Spresense in inside some of the building is working. Now we are in this lockdown or whatever you call it, and then I just tried inside my home but close to the window, and it's working. Our GNSS is very low power, and is one of those features that we added to Spresense. You can build drones with it. Anything that you need to locate an object, Spresense has already this GNSS available and integrated in it. So let's say I told you GNSS, our Spresense has the antenna already, but if you build something that you need to extend this antenna, it's very simple. You need to connect this UFL connector to Spresense, and then this resistors between, I think, R29 to R33, it needs to be modified. If you need some information, this is the information, the blue link here. You can go to this to get more information. And the table that you see here is we have the antenna in two modes. It can be passive or it can be active. Passive means it's just accessing whatever is available. Active, you extend it and you boost it up to access to the location and show you the longitude and the position of the GPS. So this is what you need to change. So it's like, for example, register number 29 by default, when you get it on the chip is closed. If you want to go to passive mode for extending this antenna, you need to open it. Or if you need to make it active, then you need to close it. But the combination of all of this, so keep that in mind. So this is another thing that I would like to mention. Let's go to this program now. So for the program, again, this is GNSS. What you see is the position. It gives you the time, it gives you the date, it gives you all of the information about the position. So the first part of this program is nothing but putting those printfs, putting those data out there. So the first part, if you see here, I have this print position, which is taking care of all of those. But before that, let me mention this. The type of satellite that you are choosing is based on your location. Sorry, we are in US, so we are using GPS. So this is everything at the beginning. You see GPS clones. This is what is available. And as you see, what I use in this example is GPS. So here I am just picking this satellite to connect with. It's this system for GNSS to connect with. So I'm using GPS in the North America. Let me go to the next page. And here, when you go to this setup, you need to start the GNSS. So we included the library. Did I tell you this? I didn't. Huh? So we have the GNSS.h here at the beginning. So this is the library that you need to include. And for that, we need to start the GNSS. When it starts, it needs to know where are you. Are you here? Are you in Japan? Or where are you? So for that, you go to this switch and you pick the GPS. For example, here I picked this GPS in the first page. So it's going to select the GPS and it's going to retrieve that data, getting the nav data and just send it back to the position, that print position that I had in the first page. And the output is going to look something like this. So you see the time. If the first kind of column is the time, but I think it's GMT here. And then if you look at the time, is kind of the minute and second is the same. But so this is 3, this is 20, this is just a difference like GMT and that. And then you see the date. So these are the printed. This is the date, this is the time, and then also you get the number of satellite that you're connecting to, and the lat and long that you are basically connecting to this for your location. Okay, so this is about the GNSS. Let me move on. How much do we have? Oh, just a second. So are we doing good with time? Okay, so we have this. I provide this file. This GNSS also is available in our example, and this is the library if you need to dig into this and learn more. By now, I covered the 3 main concept that I wanted to highlight and tell you how you can build your development around it. By now, you know camera, you know audio and GNSS, and you can access those libraries and build your application. What I have here next is actually very interesting. So when you build IoT applications, for IoT applications, you need to connect to the cloud. Sometimes you need to communicate some information. And for that, we have partnered with Necto. Necto's parent company is JIXA in Japan, and they are connecting Spresense to the cloud. Let me tell you about Necto a little bit. I have a very good example here. You see a little truck on the left-hand side. This truck is connected to 3 sensors, which is temperature, humidity, and shock. And all of these sensors are connected to Spresense. And Spresense is monitoring this truck. For example, you have ice cream moving from one location to another location, or you have some goods that you need to watch the movement, or anything in that for fleet management area. And then so basically you need to monitor this, and you're constantly communicating with the cloud to take action. So if the temperature is not in the range, so you need to take an action, for example, and communicate that to the driver, or you need to change the temperature. So all of these things has to be monitored. Necto is providing 3 cool features that you can use, and it makes your life a lot easier. First of all, Necto is, you can connect to any cloud that you want. So they are cloud agnostic. And the other thing, you can do device management. For example, you have like hundreds or hundreds of these trucks on the road, and you want to connect to this, and then you want to talk to the trucks that they are on the, I don't know, west side of the US, and just tell them to stop in the next location or do some certain procedure, and then for the trucks that they are on the east side of US do another action. Or maybe you have a factory that you need to control all of the lights or humidity or any type of environment sensor, and then you can say, like, I live in Arizona and I need to have a different setup for the temperature versus if I'm somewhere in a, like Alaska or some other cold places. So it's very easy to control your devices, IoT devices, in different places. So they are doing the device management. And also another thing that is very, very, very interesting is to control these devices, you can just write few lines of code using JavaScript. How easy is that? So you can just write a few lines of code and then control your device that is sitting on the other side of the world. So here I just wanted to introduce you to Necto. So hopefully maybe on the next webinar, maybe we build something and we show you, or maybe we talk more about Necto engine and give you more information. So this is for Necto. By the time that I get to this slide, it means that I covered everything and I talked about everything. Thank you so much for paying attention. I hope you find this helpful. And again, you find examples on Spresense example. We are going to talk about more, like maybe next webinar would be something more concentrating on AI and Spresense, but we will keep you up to date. So,
Okay, perfect.
yes, am I on time?
Thank you, Armagon. Very good webinar. I think we've learned a lot today so far. Appreciate you giving us just a thorough understanding of how Arduino works on Spresense. So for the audience, I want to thank you guys for staying with us too throughout the webinar. If you haven't already submitted your questions, please do so. I have received quite a few questions so far, and I think we need to get to those right away because I do want to be aware of the time that we do have. So the first question that I have, and Camille, you might want to hop in on this one too. The first question is, has the board been tested in low temperatures? For example, below freezing? If so, what is the lowest temperature it can handle?
Can I answer that?
Okay.
Yes. So actually, our board, our team in Japan, Tokyo, is working with a space agency in Japan, and they are building some edge devices, and it has been tested in harsh condition for space. What you see in our website, that is for like just commercial applications. But if you're targeting some application in that harsh condition, like a space, it has been tested. To tell you the exact range, we can provide that when we answer the questions for the webinar. We can include it there. But I think this way you know that this Spresense can work in harsh condition for space, and we are very excited about that. Actually.
Okay. Okay, another great question that we had, and I think this is more on the programming side of things, was, is this in C or C++? And then the other part to this that I can lump in is Arduino IDE in C? So there are two different questions. So I don't know which one of you would want to take this one.
Camille, you're the expert. Take over.
Yes, but this is of course C++, and this Arduino is using C++, so yes, so this is C++.
Okay, perfect. And then the other question that I have is, what types of audio file formats are supported for playback?
Yes, so I can also take this one. So right now we are supporting two formats, so WAV format and MP3.
Okay. All right, there's another one. How do I need to connect the antenna to use the GNSS?
No, the antenna, sorry, Camilla, I'm taking this one. So the antenna is already available. I showed in my slides that antenna is already integrated, but I showed you how to extend the antenna if you by any chance cover this on the board and you don't have the visibility. So no, the antenna is already there.
Okay. Here's another interesting and good question too. So I'm glad that people are putting them into the question section. What is the lowest power consumption in sleep mode?
So in deep mode, yeah, if we need to modify a little bit of hardware, and then we can go in deep sleep up to 6 micro amperes.
Okay. And another good one, they're just coming through like crazy. Does Spresense support the Circuit Python from Adafruit?
Okay, what's the question?
The question is, does Spresense support the Circuit Python from Adafruit? Yes.
Yes, we have the king of CircuitPython here, guys. You're very lucky to have Camille on this call. So he is doing, Camille, please just tell us a little bit about CircuitPython and the development that you're doing for Spresense.
Yes, so yes, Spresense supports CircuitPython right now, maybe only in basic area like basic interfaces like I2C, SPI, UART, but we want to add more advanced features like GNSS. GNSS is ready to use, I mean, from today, because today module for the for GNSS was merged to the master, so it means that you can right now use the GNSS on CircuitPython with Spresense. But in the future, we would like to also add another feature of Spresense, like camera, for example. But for now, from the advanced feature, we are only supporting GNSS.
Okay.
And let me add a little bit of thing. Maybe, so this webinar is concentrating on Arduino. So this series, like this tree that we have is Arduino, but maybe we offer our next series for supporting like how you can program with CircuitPython and so on. If we see that there is interest, we may do that.
Okay. Another good question here. Does Spresense support additional modules for NB-IoT?
I am not familiar with that, but I can check.
Maybe we can answer after the webinar.
Do you know?
Because we need to check. I don't know, so I need to check this.
Okay, so we'll get back to you with that one. And then another one, is Necto software ready for enterprise level deployment?
Oh, we are excited about this. So Necto, we are working with Necto, so they are integrating some of the features. And I think we can provide you with the link to their website, and you can get the update from there. But we are almost there, I think, for in that level. But I will get more information, more up-to-date information with Necto, and I will share with then you answer the questions.
Okay. We're about at the bottom of the hour. I do want to get 2 more questions in, and then we'll do a wrap up. So this is another good one. Do you have a good simulation tool where you can test how a larger number of Spresense boards are working together?
Yes, this is a very good question, actually, because Spresense by itself, when you look at it, you cannot see all of these features and capabilities. So what we are doing, we are working with a company named Gambit, and we are building the simulation for different scenarios. Like, for example, you have an agriculture field and you need to put Spresense sensors and Spresense in this field, and you need to monitor this field. So we can do the simulation to give a better visibility to what we do and how we can implement it. Yes.
Okay, and then the last question I'll take for now is, can I capture a 5 megapixel with the Spresense camera?
Yes, you can, but unfortunately right now in current implementation of the Arduino not. So if you want to capture a 5 megapixel camera image, then you need to use the NATIX, and then you need to modify memory layout and something like that, so it's more advanced.
Okay, perfect. So thank you for all your questions, some really good questions. As I mentioned before, we'll get to these questions in a question and answer document and send them out in about a week or so. But as I said, you will receive the slide deck that we went through today. You'll also receive the link. You'll also receive the on-demand version of this webinar in another week or so. We do have another webinar in this series, which will be on the 25th of September. If you do need to be on my mailing list, please let me know and I'll mail it out to you as well as the other list that we do have. So please stay tuned for your invite. Earlier when I started, I also mentioned that we will have a draw for a Spresense kit, which includes the camera board, the main board, and the extension board. And on June 30th, we will notify who the winner is. And if you're not following Framos or Sony's Spresense on LinkedIn or Twitter, please do so, because at that time you'll receive a lot of company information, product launches, webinars, and virtual events. Thank you so much again for staying with us. We appreciate your time. You have a great rest of day, and we look forward to you on the next webinar. Bye-bye.